All right, so we're going to now formalize this. We're going to bring out the big ideas that you need to remember for things like AP exams, tests, talking to people at parties, you know, that type of thing. So after all, who doesn't come across conversations talking about outliers, and the least squares regression line? Two big important ideas today. First one, we're going to talk generally about the scatter plot after I fix mine. This is why you have a straight edge with you all the time. An old gift card works really, really well. So Y bar and X bar. Look at those precision arrows. So your x-axis, y-axis. And then you've got your least squares regression line that, again, kind of goes right through the middle of the data, but more importantly, it goes through the point X bar, Y bar. And as I was saying in the last video, it's kind of like a seesaw. So depending upon where you're putting the pressure or the weight, it's going to affect the seesaw differently. Cause it to go up and down, particularly if you're moving things, if you're having the outlier deviate along the x-axis away from the prime, or for wait, not prime, the x bar. So good least squares regression line has a low standard error value and has a high R squared value. Remember, the R squared value is what percent of the, I don't want to say fluctuation, what percent of everything. Oop, we're already on mode number 2. Now the least squares regression line, and here's the formula that you're going to be playing around with here, is the prediction line is equal to B sub O, which is your y-intercept, and then your slope, B1 times X. Now, B1 is found by taking your R value. Oops, apologize for that. And you're dividing by the standard error of the Y value, or the Y variables, and the standard error of the X values. And then for your initial starting spot, not surprisingly, you're going to take the slope and you're going to modify it by the point X bar, Y bar. You're effectively plugging it into point slope form. Or what you could do with that, and then it's going to back itself out. So again, as usual, hit pause on this. Go ahead and work through this, and then come on back and double check your answers. We were talking about Major League Baseball salaries back in 2016, total payroll for those salaries. Payroll in millions of dollars is down on the x-axis, and the thought process, obviously, is if you're spending a lot of money on really good players, you will come up with more wins. So describe the info. They tell you that the Los Angeles Dodgers are on the far right, so that's LA. The Cleveland Indians are in the upper left. And that specifically would be, I'm assuming I'm getting, there we go. So the first question is, what influence does the LA Dodgers have on the equation? And since it's the Y value, it's going to, remember, it's going to draw up the y-intercept. The slope is going to go down. So LA is on the far right. Below the least squares regression line. So what's that going to do? Remember, lines always are attracted, or like curves are always attracted toward the outlier. So the line goes down, so this decreases the slope, and the y-intercept increases. Now you know the same thing with Cleveland. Again, we're talking about what the residuals are. So you've got this residual there. So because the Cleveland Indians, because Cleveland has a large residual, again, we know that because it's far away from the y-axis, or the least squares regression line in the y value, it makes your standard deviation, just trying to figure out there for a second, standard. So it makes your standard deviation greater because it's going to give it more variability because this is further away, as we found out yesterday, and the R squared is smaller. All right, so now here's an example of how you can use some of your equations. So I give you 15 random high school students. We're checking out the relationship between their height and their length of their foot. So the question is, what is the average and what does it mean? Misread that? My apologies. So again, remember B1 is going to be your R value, which we know is 0.697. We're going to multiply that by the quotient of the two standard errors. So 10.69 divided by 2.71. So we end up multiplying all that up, you get 2.75. And then B sub 0 is going to just equal the average minus the x average being run through the slope. And that is that. So then we're going to come up with effectively y hat this way. Now this is something where initially we will eventually in chapter 12 figure out how you guys can do all this by the calculator. For right now, the data set's going to be small enough you're going to have to do it by hand. So please be prepared for that. And with that, we're going to come to the end of Outliers and least squares regression lines and the outline and the end of chapter 3.